Guys, welcome back with another interesting problem for you all. Students in China at the Nanjing University of Aeronautics and Astronautics had to solve a math problem to connect to the internet at one of the dining halls. Here's the problem that went viral. It's the integral from -2 to 2 of the following quantity: x cubed cosine of x over 2 plus half times square root of 4 minus x square. The Wi-Fi password is the first 8 digits of the answer. Now, you can't use the internet to solve this problem because you're trying to get the Wi-Fi password, and you're also not allowed to use the calculators. Can you figure it out? Give this problem a try. When you're ready, keep watching the video for a solution. So, how would we solve this? Well, we'll first distribute what's in the parentheses by multiplying each term with square root of 4 minus x squared. So, we have two separate integrals. That is, integral from -2 to 2 x cubed cosine of x over 2 times square root of 4 minus x squared plus integral from -2 to 2 half times square root of 4 minus x squared. Now let's consider the integral on the left. We can evaluate it by considering even and odd functions. So let's check if it is even or odd. So this is the function f of x equals to on the left hand side. Then we plug in -x in place of x. So we get -x the whole cube times cosine of -x over 2 times square root of 4 minus of -x the whole square. Then we get f of -x equals to -x cube cosine of x over 2 times square root of 4 minus x square. So -x cube is an odd function, cosine of x over 2 is an even function, and square root of 4 minus x square is an even function. We can put these all together to conclude the product of these function is also an odd function. Therefore, f of -x equals to -f of x. Now, if the function is odd, recall the integral of an odd function over a symmetric interval from -a to a is 0. Because half the area is negative. The areas above and below the x-axis are equal. This means this entire integral vanishes and is equal to 0. Therefore, this whole function on the left hand side is equal to 0. Now, just for your knowledge, let's see if the function is even. For example, f of -x equals to f of x. Then, the integral from -a to a f of x is equal to double the area. The area under an even function over a symmetric interval can be calculated by doubling the area over the positive x-axis. When the limits of integration are from -a to a, it involves two equal areas because they are symmetric about y-axis. So we'll not consider this as our function is odd, and hence the left part equals to 0. Now, how do we solve this integral? Let's take square root of 4 minus x squared equals to y. Now squaring both sides, we get y squared equals to 4 minus x squared. Bring the variables one side, x squared plus y squared equals to 4. Alas, it's a circle. Remember that x squared plus y squared equals to 4 is a circle centered at 0, 0 with radius of 2. So we can graph the square root of 4 minus x squared as being a semicircle with radius of 2, and it will be on positive y-axis. We want to calculate the area under here, and then we want to take half of the area. Therefore, integral equals the area. So we have half the integral from -2 to 2 square root of 4 minus x squared, and that integral is area of semicircle, half of the circle. Half times area of circle is pi r square, and half of that because it's a semicircle. So half pi r square. Let's substitute the radius, which is 2. So half times pi times 2 squared. So 2 and 2 gets cancelled with 2 square. We get pi. So that's the answer. Pi is the answer of the Wi-Fi password.